Hey, my name is Amari Owens, and this is my public lecture review number two, where I'm going to talk about the 2025 Physics Nobel Prize explained by Professor Brian Kennedy, which occurred on November 10th from 6:30 to 7 p.m. in the Koch 144. Um, Basically, we're just gonna talk about a thing. So, it was essentially a discussion on the how the 2025 winners conducted the experiment on quantum mechanical tunneling. It was a very intricate idea. I'm still kind of trying to wrap my idea. He talked about something called Josephson junctions, Cooper pairs, and like the macroscopic world, Schrodinger states, and then just like an idea. It was actually a very complex topic, and I think even with my level of knowledge, I still didn't kind of understand what he was trying to explain. But I did watch some videos on it, so I think I'm going to try, hopefully, and explain it in a better sense right now. Um, So first, I'll just kind of get into like the questions I need to talk about. So like something I didn't know were Josephson junctions and like the idea of quantum mechanical tunneling. He also talked about something with sine and phi functions of light, which was a really hard concept to like wrap around. So I'm still trying to figure that out simply. But what did I learn? Something that I already knew. I kind of already knew the Schrodinger equation. I've like seen it briefly, and with like Schrodinger's cat, it's always just a popular concept. So I was briefly familiar with that. Um, Something in lecture that I really sparked my curiosity. I guess like the idea of like quantum tunneling, which is kind of like weird, like because I actually explored this a little bit, and like I think I can finally unexplain it. But basically, what they did in the experiment was like they basically like they had like this microscopic object, which I think was like light, and they like sent it through like a wall or some barrier, and like normally like the light shouldn't have gone through the barrier, but due to quantum mechanical tunneling, like it went through the barrier because of the basically like the superconductivity of the area of like the electric particles. He used a bunch of math, and I really did not understand that. That was really confusing for me. But it's I haven't even looked into something like quantum mechanics, so this is very hard to explain. Um, I think he kind of explains superconductivity. It's like this idea of like highly charged particles, right? So I think like when particles kind of get supercharged, they start to like link together, and I think they start to form Cooper pairs. And Cooper pairs are basically just like big electron particles, essentially, right? So like if we form enough Cooper pairs that like kind of become like this long object that like somehow like it just has like it's in the state of superconductivity, which I guess works well with the barrier. So like because of that, it was able to easily slip through the barrier. Again, still like a very hard concept that I did not understand and probably need some stuff. Um, I wrote something down actually in the lecture. It says environment localizes the particles, and then number of particles changes on superconductivity. So that I think that might kind of help. Maybe like the environment number of particles are changing because like the superconductivity is producing Cooper pairs, and the Cooper pairs are like changing number of particles. So like the number of particles allows the object to simply just pass through the barrier, which yeah, it was a very complex idea, but it was a very interesting idea. Do I think it really relates to my field of study, which is computer science? Not so much, but you never know. There's always something kind of like out there, and I hope it was a really great experience. Well, thank you, and I enjoyed this. Bye.